Hello, today we're going to start the process of turning this idea into a reality. People have been building dune buggies for over 50 years now, and although the basics are usually similar, Volkswagen engine and transmission and Volkswagen suspension, there are limitless options that you have on building a dune buggy. If you stayed with Volkswagen engines, you could have any number of these engine sizes. And that doesn't even count different cam, carb, head, forced induction, or any other options on a Volkswagen engine. Or you could use any number of other engines out there. Today, most people you see will be in some sort of very capable side-by-side. Although for me, building is as fun as the driving, so I wanted to do something a little different. I built a relatively simple VW pan buggy in high school and have been dreaming about building another one for 10 years now. First things first, I need to have a plan. I've always wanted to design and build an A-arm suspension setup, so in the front we will be doing that and aiming for about 12 inches of travel. I'm planning to use Polaris 800 coilovers to keep the costs down. I say to keep the costs down, but I'm going to go spend over $1,000 in Heim joints and hardware anyway. In the back, we're also aiming for about 12 inches of travel, utilizing the stock Volkswagen torsion bar. This will be limited by our CV angles. For the initial build, I will be installing a stock Volkswagen 1600 single port because I have enough used parts to build one. I would like to build a turbo 1600 or rebuild my 2110cc Volkswagen engine at some point. I already have a 5-rib bus transaxle, so we'll be using that. If you are racing the Mint 400 in a vehicle that weighs less than 2,000 pounds, the minimum tubing size required is 1.5 inch by 0.95 DOM or chromoly. Since our buggy will weigh closer to 1,000 pounds and not see too high of top speeds, I'm going to use 1.5 by 0.95 ERW tubing. Although this isn't as strong as DOM or chromoly, this will be adequate for our cage. Alright, now we have an overall plan. Let's get started on some details. Today we will be designing and building the spindles, or the uprights for the front A-arms. These are the sub-steps for the uprights. The first step was laying out the suspension and racing aspirations. It is a great resource and gives me more information that I know what to do with. I was focused on getting all of their main specs in the good category. This includes roll center, camber gain, scrub radius, and bump steer. After all of my geometry looked good, I started to transfer it into SolidWorks. I scanned the Super Beetle spindles that I was going to use. This will help create pieces that will contour to them nicely. I've been using the Shining 3D Einstar for a while now. It seems to work pretty well for the generally larger projects that I'm working on. Most of the time I downsize the file quite a bit and lose some details so that SolidWorks can handle it easier. Here you can see my boxed in assembly with the points I got from racing aspirations. I used all 3mm plate for this piece. I did have to do some calculations for the length of the steering arm so that my steering box would use the full range of motion of my ball joints. I also created this 3D printed jig to hold the steering arm to the correct height and hold the spindle in place so that it has the correct toe and camber in relation to the rest of the piece. I exported my DXF files and loaded these into SheetCam to create the G-code for the plasma. Here's what some of the parts look like nested and ready to export the G-code. Then I got some steel loaded up on the plasma and started cutting. After the pieces were cut, I marked the bend lines and got the bend angle from SolidWorks. I hadn't done this before, but with the angle finder on this little press brake, I actually got some really accurate parts. The edges of your part on the bend line should be perpendicular to the bend. I didn't really know exactly why until I was doing this myself. So what happens is the bend tries to take the path of least resistance, and since there's less material here and it is unsupported, the bend takes a path more similar to this red line that I drew. For this part it is just fine, but for some parts that warping could affect fit or function. I didn't have access to my sandblaster, so I got to spend some quality time with the Dremel cleaning these spindles. In the middle of this, I decided to mess around and buy a lathe. This will help me make bushings that have better flatness tolerance on the ends than if I was using them straight off the bandsaw. I am way new to this, so I don't think I was doing this properly, but I did get some parts that were good enough to use. Here you can see why the bushings are important. They will be holding the distance of these plates, as well as keeping them parallel to each other while I am welding. Final check of camber of the spindles versus the plates before tacking into place. Side note here, all of the steel I'd been using up until this point was pickled and oiled, although this stuff was not, which means that it still had mill scale on it. Mill scale is basically a thin layer of oxide that is on the steel after it is formed from hot rolling. I can demonstrate this by laying a hot weld and letting you watch the backside of this plate. You can see the mill scale flake off when I drag the screwdriver across it. It is not ideal to leave this on for welding or painting, although I did because I didn't know better. It shouldn't be a problem, but only time will tell. One way to get rid of this on your own parts is to let them sit in vinegar for a while, and then the mill scale will usually brush off. This is a similar process to pickling when you ordered pickled and oiled steel. I'm not sure if these spindles are cast iron or cast steel. Cast iron can have problems with being very brittle when welding to it. After I tacked it together and before laying down actual welds, I put the whole thing in my oven at 500 degrees. I also covered it with a towel to let it cool down slowly when I was done. This should minimize the chance that I will see any cracking. I mean, if this part fails, it's not that important, right? For paint, I'm using self-etching primer and a single-stage urethane paint from Eastwood. And for the sprayer, I have a cheap HVLP sprayer from Harbor Freight. I set up a little paint booth with filters and fans on the backside, pulling air through and out of the shop. It worked pretty well. At the end of all this, I think they turned out pretty well. Hopefully they're strong enough to hold the wheel on, and hopefully they don't flake off all the paint. Thanks for watching, and join next time for the next steps of the Buggy build.